In 2024, motorcycle recall notices hit levels not seen in the previous decade. This is not because defects are being caught faster. It is because the defects are getting worse and recalls are rising. In this investigation, we are going to expose the factory system destroying the modern motorcycle and show you the only 3 categories of bikes you should actually be spending your money on right now. If you walk into a motorcycle showroom today, you might believe you are looking at a competitive marketplace. You see Honda, Yamaha, Kawasaki, and Suzuki. You see BMW, KTM, and Ducati. You see Triumph, Royal Enfield, and Harley-Davidson. And you assume these are different companies with different engineers and different philosophies, competing to build you a better machine. That assumption is costing riders thousands of dollars they will never get back. The reality is that platform consolidation has swept through the motorcycle industry with the same force it hit the automotive world. The same engine architecture, the same frame platform, and the same electronically controlled components are being stuffed into motorcycles carrying completely different nameplates and sold at completely different price points. A KTM 890 Duke and a Husqvarna Vitpalen 901 share the same engine. A BMW S1000RR and several KTM platforms share engineering DNA through their parent company relationship. The nameplate is a marketing decision. The engineering is shared. And when that shared platform carries a defect, every motorcycle built on it carries that defect, regardless of what badge sits on the tank. The problem starts before the motorcycle ever leaves the factory. It starts with the people on the floor who are building it. In the era when Japanese manufacturers built their reputations on reliability, assembly line quality control was a cultural obsession. Workers were empowered to stop the line when something was wrong. Stopping the line was not a failure. It was the system working correctly. That philosophy produced engines that ran for 300,000 kilometers on nothing more than regular oil changes. That philosophy is gone. The metric driving every decision on a modern motorcycle assembly floor is units per shift. The plant manager's performance is measured against it. The line supervisor's bonus depends on it. If the line stops, revenue stops. If a worker flags a defect and pulls the stop, the shift quota takes a hit, and someone has to explain why to someone above them. This creates a system where flagging a problem is a career risk, and moving the unit down the line is the path of least resistance. That is why technicians across the industry are finding the same categories of fault on brand new motorcycles. Improperly torqued engine cases, coolant lines routed against frame sections that vibrate against them for 2 years before they fail. Electrical harnesses bundled with connectors that oxidize in precisely the pattern that puts the fault outside the warranty window. This is not sloppy workmanship. This is the predictable output of a system that rewards speed over quality at every level of the organization. But the incentive problem on the factory floor is only half the story. The materials themselves have been engineered to fail on a schedule the manufacturer already knows. The most consequential engineering decision in the modern motorcycle industry is the adoption of the highly stressed, small displacement parallel twin as the default powertrain across almost every mainstream category. On paper, these engines are impressive. High specific output, strong fuel economy numbers, lightweight, competitive price point. In practice, they are engineering grenades with a mileage fuse. To extract the power figures that win comparison tests and justify premium pricing, Manufacturers are running these engines at compression ratios and thermal loads that would have been considered racing territory a decade ago. The tolerances are tight, the stress is constant, and the maintenance intervals that the manufacturer publishes in the owner's manual are calibrated to look competitive on paper, not to keep the engine alive at those stress levels long term. The result is a documented pattern. Cam chain tensioner wear appears between 30,000 and 50,000 kilometers on highly stressed parallel twin configurations. Valve seat recession requires full headwork on engines that are barely 3 years old. Oil consumption begins at mileage that a naturally aspirated engine from 2005 would have considered early service life. Independent mechanics who service both modern high-stress twins and older naturally aspirated configurations describe the difference consistently. The older engine at 80,000 kilometers is midlife. The modern twin at 50,000 kilometers is showing wear that belongs at 150,000 kilometers. The engineers who designed the modern engine knew those tolerances. They published maintenance intervals that obscure the degradation curve until the warranty expires. And if the engine is the first trap, the electronics sitting on top of it are the second. A 2003 motorcycle had a handful of sensors, a basic fuel injection system, and an ECU the size of a paperback book. When something went wrong, an experienced mechanic could trace it with a multimeter and basic diagnostic knowledge. The repair was accessible. The cost was proportionate. A 2026 motorcycle carries ride-by-wire throttle systems with multiple control modules between your hand and the injector, cornering ABS with inertial measurement units that require annual calibration to function accurately, and TFT dashboards that control riding modes, traction intervention, and connected services through a single glass panel that costs $1,500 to replace when the processor fails from vibration. Every one of those systems is an additional failure point. Every one of those failure points requires proprietary diagnostic software to access. Every one of those diagnostic accesses costs you money at the only place that has the software, the authorized dealer charging $200 an hour. Bosch, the supplier behind the ABS and traction control units fitted to the majority of modern motorcycles across all major brands, has documented specific failure patterns in their inertial measurement unit housings when exposed to the vibration profiles of single and parallel twin engines. The manufacturers who fit these units know the failure pattern. The warranty period was set to expire before the failure rate peaks. You are not buying a motorcycle with advanced safety technology. You are buying a machine with multiple failure points on a documented timeline, surrounded by a warranty structure designed by lawyers who already knew where the failures would occur. The extended warranty you bought to protect yourself was written by the same legal team. It was never designed to protect you. Every warranty claim you file is reviewed against an exclusion list that runs to dozens of pages of fine print. Cam chain tensioner wear is excluded as a maintenance item. Valve seat recession on a high-stress engine is excluded as normal wear, accelerated by rider behavior. Electronics failure caused by vibration is excluded because the unit was not damaged, it simply wore out. The manufacturer's legal team spent months constructing an exclusion architecture specifically around the failure modes their engineering team identified during pre-production testing. They knew where the bikes would break. They built the warranty around those breakpoints. You paid for coverage that was designed to cover everything except the things most likely to fail. Meanwhile, you are still making monthly payments on a motorcycle sitting at the dealership, waiting for a back-ordered part the service advisor told you would arrive in 4 to 6 weeks. That conversation was 2 months ago. So, what should you actually buy? Here is the ranking that dealers will never show you. Any current generation Honda, Yamaha, or Kawasaki in a naturally aspirated configuration with conventional fuel injection. Not the highly stressed, high-output version designed to win a dyno comparison. Choose the honest, slightly less impressive version that will still be running reliably at 150,000 kilometers. The Honda CB500 series, the Kawasaki Z650 before the latest high-stress revision, the Yamaha MT-07 in its earlier naturally aspirated configurations before output targets began pushing the engine beyond its comfortable operating envelope. These are not the bikes that win comparison tests. They are the bikes that independent mechanics recommend when their customers ask them directly what they would buy with their own money. That recommendation means something. The golden era of modern motorcycle engineering runs roughly from 2000 to 2015. Fuel injection had fully matured. Frame geometry and suspension technology was sophisticated. Anti-lock braking systems were available. But the output targets had not yet pushed engine stress levels into the zone where longevity becomes a genuine concern. A Honda CBR 600F from 2011, a Kawasaki Z1000 from 2010 to 2013, a Triumph Street Triple from 2013 to 2016, before the platform moved to the highly stressed 765 cubic centimeter configuration. These engines were not engineered to achieve a specific power figure for a press launch. They were engineered to run. The difference between an engine designed to impress a journalist on a test day and an engine designed to last 200,000 kilometers is not visible on a specification sheet. It is visible at 80,000 kilometers when one of them still feels tight and the other is burning oil. The best value in the entire motorcycle market is a Japanese domestic market import sitting in the 25-year import window right now. Japan's Shaken Vehicle Inspection System is a government program so rigorous and so expensive that Japanese owners often sell motorcycles at low mileage simply because they cannot justify the inspection cost as the bike ages. A 1999 Honda CB 1300 Super 4 or a late 1990s Yamaha JX 1300 version. Entering the legal import window right now can be purchased with original mileage that a comparable used bike in any Western market would never carry. These machines were built during the period when Japanese manufacturers were competing on engineering integrity as a primary sales argument. The metallurgy is heavier, the tolerances are tighter, and the components were designed to run at their rated outputs without stress. 25 years of careful Japanese ownership barely registers on the wear curve of an engine that was overbuilt for its application from the day it left the factory. You are not buying an old motorcycle, you are buying a fully depreciated machine, maintained to a government standard that does not exist anywhere else in the world, carrying a drivetrain architecture that was designed to last before the industry decided planned obsolescence was more profitable than durability. Check the injection system, check the stress level of the engine, and never let a comparison test power figure distract you from the question that actually matters. Will this engine still be running cleanly at 100,000 kilometers? If this opened your eyes, subscribe, hit like, and tell me in the comments. What year is your bike, And how many kilometers has it covered without a major repair?